In this video, we'll be writing names and formulas for acids. First, we'll do a quick recap of the difference between oxyacids and binary acids. Let's go to our handout. So, as you can see over here, an acid is a substance that will ionize in water to produce what's called H plus ions or hydronium ions. So, for example, if I take some HCl and I put it in water, so I'm going to put aqueous here, which means dissolved in water, that means aqueous, it should ionize, so the H and the Cl will separate to form some H plus ions dissolved in water, plus Cl minus ions. And it's this H plus here that makes that HCl an acid because it increases the H plus in the water, and as a result would decrease the pH of the water. And if you have a substance that's acidic, overall a solution is acidic, the pH would be less than 7. And it has to do with that H plus there. So most of your acids, or all your acids, are going to start with an H in their formula. And they'll end with AQ in the formula because they need to be dissolved to be acting as an acid. Now, acids can be of two types. They can be binary acids and they can be oxyacids. So if you're dealing with binary acids, you have an acid that's made up of an H and a non-metal ion. So for example, if we look over here, we have H2SAQ. This is a binary acid. Binary again meaning two, only two elements in it, H and then the non-metal. So only two elements in it. Notice how there's an AQ there, aqueous, because it's dissolved in water to act as an acid. Now, the name of a binary acid is always going to have the prefix hydro in the front. So if you don't see hydro in the front in its name, it's not a binary acid, it's the other acid called an oxyacid. An oxyacid is an acid that has, let's go down here, H and a polyatomic ion with O in it. So it's an acid with H and a polyatomic ion with O. So for example, if we go over here, we have H2SO4. So there's H, and then there's a polyatomic ion sulfate, which has O in it. So this is an oxyacid. So contains polyatomic ion with oxygen in it. Now the name of an oxyacid does not have hydro in the front. The name of an oxyacid does not have hydro in the front. So if we're looking at names, hydrochloric acid, hydro, that's binary, because the name of a binary acid starts with hydro. And we know it's an acid because, well, we have the word acid there. If you look at chloric acid, that's an oxyacid. There's a polyatomic ion in there that contains O. How do I know it's an oxyacid, not a binary acid? Well, there's no hydro prefix. And so that's a bit of a recap. You would have probably learned that a little bit in grade 10. But if you didn't, now you have some background information about acids. They will ionize, meaning they separate in water to increase H+. And we say ionize because you'll notice HCl is normally a molecular compound. So there's really no ions in there if it's not dissolved in water. But once you dissolve it in water, it does form ions. It ionizes, it transforms into ions, and specifically H+ there. And like I said, you do need to have the AQ there. If I didn't have the AQ, we'd call it something different, and we'll go over some examples of that. So let's start off with binary acids. Like I said, there are two elements in there, an H and a non-metal ion, which is generally an anion. It's a negatively charged ion. So when you're writing a name from the formula, you start with the prefix hydro, and then you write the root of the non-metal. but you have to replace the ending of the nonmetal, INE, to ic, not ide, but ic. And then you put the word acid at the end. So for example, first let's identify that we have a binary acid. It starts with an H, and there's nonmetal there, only 2 elements. And there's also AQ in the formula. So this would be called hydro. Now normally, the Cl is chlorine. So we change its ending to chloric, hydrochloric, and then space acid. Now you need to have an AQ there. If you don't have an AQ, like this case here, HCl, gas, it's not acting as an acid right now. It's acting as the molecular compound HCl. And as you may remember from molecular compound rules, you can call this hydrogen chloride or monochloride. So it needs to have AQ, not an acid until you dissolve it in the water. Now, let's go to HF. Same idea. So you can pause the video and try it yourself. We have hydro because it's a binary acid. Fluorine becomes fluoric with a C there, and then acid. Then here, H2S aqueous. So binary acid again, hydro. Sulfur becomes sulfuric, not sulfic. I see that a lot, not sulfic, sulfuric, hydrosulfuric acid. And that's how you would name binary acids. You can also write the formula for binary acids from the name. And so what you do is you do a crisscross between the H and the nonmetal that's there, and then you add aqueous as the state. It's not really a state, it's just that it's dissolved, so you add aqueous at the end. So for hydrochloric acid, we have H, and it's in group 1, so we're going to put a charge of 1 plus. And then Cl, chloric, I know that because it's chloric here, Cl, and that's -1. Crisscross, and we get H1Cl1, and we can clean that up to get HCl, and then we put AQ because we said it's the acid. You can pause the video and try the rest on your own, and then check your work after. Here we have hydroiodic acid. So hydro, we know it's binary, so H1 plus, only going to be an iodine here from iodic there, 1 minus, crisscross, and we get H1, I1, H, I, AQ. Hydrobromic acid. So again, binary because there's the word hydro in the front. H, Br, H1 plus, Br, 1 minus, crisscross it, we get H1, Br1, which is H, Br, and then AQ. Hydrosulfuric acid. So we have H1 plus, S2 minus, crisscross that, and we get H2S1. We don't need the 1 there, and we clean it up, so H2S AQ. And that's how you would write formulas for binary acids. Just a little caution here. When we get into naming acids, students, they really get into it, and they forget that some compounds that start with an H are not acids. So for example, H2O is not hydroxylic acid. This is just water. And this is neutral. So just don't get carried away when you see that. And also, some students might see this. They'll see H3N. If you look carefully, it's usually not written this way. Be careful. This is actually NH3, and that's not an acid. This is ammonia. And ammonia acts as a base. So don't get carried away. Remember that, yes, this has an H in front of it, but it's not an acid. It's still water. Um, in the next video, we're going to learn how to name and write formulas for the oxyacids.